All right, let's get into it. If you're prepping for the AWS Certified Developer exam, you know Kinesis is a big deal. In this explainer, we're going to cut through all the noise and break down exactly what you need to know to absolutely ace those Kinesis questions. Here's the goal. By the time we're done here, you'll be able to spot a tricky Kinesis exam question from a mile away and know precisely how to answer it. We're focusing only on the core concepts that you'll actually see on the test. So we'll kick things off with the big question, stream or queue? Then we'll pop the hood on Kinesis to understand shards and keys. After that, it's all about getting data out, handling the inevitable errors, and finally, we'll wrap it all up with a rapid-fire checklist to really make it all stick. Let's do this. First up, let's clear up one of the most common points of confusion. When on earth do you use Kinesis, and when would you reach for something like SQS? I mean, they both move data around, right? Well, yes, but they're built for completely different worlds. Just look at this table. The differences are night and day. With SQS, a message gets picked up, processed by one consumer, and poof, it's gone. Kinesis is totally different. It's more like a replayable log. The data sticks around for a while, which means multiple different apps can all read and even reread the exact same data. That replay feature, that's a huge deal for streaming, and it's something SQS just wasn't designed to do. Okay, so here's your classic exam scenario. You're tracking every single click a user makes on your website, and you have to process those clicks in the exact order they happened. For this, you absolutely have to choose Kinesis. Why? Because Kinesis guarantees the order of records, but only within a single shard. So you just use the user's ID as your partition key, which forces all of their clicks onto the same shard, perfectly preserving their session. SQS standard queues? No way. They make zero promises about order. And this quote right here just nails it. Think of Kinesis as a high-speed, multi-lane data highway where tons of cars can drive and see all the same traffic. SQS, on the other hand, is more like a super reliable post office, delivering one package to one recipient at a time. It's all about decoupling your application. Great. So now we know why we'd use Kinesis. Let's take a look at how it actually works. You really have to get your head around shards, partition keys, and throughput. They're the absolute building blocks of Kinesis. The single most fundamental unit in Kinesis is the shard. And honestly, that data highway analogy is perfect. Every shard is its own independent lane with its own speed limit. So if you've got one shard, you've got a single-lane country road. 10 shards? Now you've got a 10-lane superhighway. So if the shards are the lanes, how does Kinesis decide which lane your data drives in? Well, that's the whole job of the partition key. You give each piece of data a partition key, something like a user ID. Kinesis hashes it, and that hash value determines exactly which shard it goes to. That's the magic trick that guarantees all data for the same user stays in the same lane in the right order. And this diagram here shows the whole journey. Over on the left, you've got your data producers, your web servers, your IoT gizmos, all sending in data. In the middle, there's our Kinesis highway, neatly organizing everything into shard lanes. And on the right, you have your consumers, Lambda functions, analytics tools, reading that data to do something smart with it. All right, here's a number you absolutely have to burn into your memory for the exam. Every single shard, every lane on our highway has a strict speed limit. For writing data in, that limit is 1 megabyte per second or 1,000 records per second, whichever you hit first. That is a hard and fast rule for each shard. So, if an exam question asks how you get more write capacity, the answer is always the same. You add more shards. It's that simple. It scales perfectly. You need 5 megabytes per second of write capacity? You create a stream with exactly 5 shards. Done. Okay, we've successfully pushed our data onto the stream. Now, how do we get it back out? And how long does Kinesis even keep it around? Let's talk about consumers and retention. First, an easy one for the exam. By default, Kinesis keeps your data for 24 hours, but you can change that. And the absolute maximum you can set it to is 365 days. So if you see a question about replaying data from months ago, you know it's possible. Now this is a huge one for the developer exam. Let's say you have 3 different Lambda functions, and they all need to read from the same stream. If you use the standard approach, they all have to share a single 2 megabyte per second read limit from each shard. It's like they're all stuck in the same traffic jam. They're going to slow each other down. The solution? It's called enhanced fanout. This gives every single consumer its own private, dedicated 2 megabyte per second express lane. They don't interfere with each other at all. So what happens if your consumer application just crashes halfway through processing? That's where checkpointing saves the day. Your consumer, usually with help from a library called the KCL, periodically saves its progress. It's like putting a bookmark in a book. If the application crashes and restarts, it just looks at its last bookmark and picks up right where it left off. This is absolutely key for building fault-tolerant systems. Okay, we've covered the happy path, when everything just works. But we all know the real world is messy. So let's talk about what happens when things go wrong and how you can do some real-time analysis on that data as it's flowing by. This right here is a critical concept, a huge gotcha for the exam. When a Lambda function reading from Kinesis fails to process a batch of records, it doesn't just skip them. No. By default, it will try that exact same batch over and over and over again. And here's the kicker. Until that batch succeeds or the data finally expires, it completely blocks any new records from being processed on that shard. Everything grinds to a halt. And on the flip side, what about the producers? What happens if they try to break that 1 megabyte per second speed limit? Well, Kinesis puts up a stop sign. It throttles you. It'll reject your requests and send back a ProvisionedThroughputExceeded error. This means your application code has to be smart enough to catch that error and retry, probably with some kind of backoff. So how do you solve that terrible shard blocking problem? That one bad record that causes the whole batch to fail is often called a poison pill. The good news is, for Lambda, you can now configure this. You can tell it to split the batch to find the single bad record, or you can have it automatically send the entire failed batch to a dead letter queue. If you're building a consumer from scratch, though, you have to code this yourself. A good old try-catch block to isolate the poison pill, send it somewhere else, and let the rest of the batch succeed. Okay, what if you want to analyze the data while it's still in motion? Like calculating a running average of stock prices or counting user clicks per second. The go-to service for this is Amazon Kinesis Data Analytics. It's amazing. It lets you run standard SQL queries directly on your live flowing stream. It's incredibly powerful stuff. We have covered a ton of ground, so to make sure this is all locked in for exam day, let's do a final, super fast review of the top 10 things you absolutely have to know. Okay, you ready? Let's blast through it. Number 1, Kinesis for order, SQS standard for not order. 2, partition keys get hashed to pick a shard. 3, a failing Lambda blocks its shard by retrying the whole batch. 4, need more write speed? Add more shards. 5, enhanced fanout gives every consumer its own private lane. 6, max data retention, 365 days. 7, the KCL uses checkpointing to survive a crash. 8, real-time SQL on a stream, Kinesis Data Analytics. 9, writing too fast gets you throttling errors. And 10, handle poison pills with Lambda failure settings or your own try-catch logic. Got it? And that is our deep dive. You now have the essential mechanical knowledge of how Kinesis really works and, more importantly, how it's tested on the developer exam. So the only question left is, what awesome real-time app are you going to build with it? Thanks for joining me.